Well, a very good afternoon to you all. It's wonderful to see you in larger numbers, I would say, on this momentous occasion. As you all know, we have embarked on a year-long journey to celebrate the 20 years of the sojourn of BITS Pilani KK Goa campus. Dear faculties across the campuses and students, it's a very special day, and commensurate with our tag as Institute of Eminence, one of the Institute of Eminence in the country, and all the academic excellence that we have amassed over the years, all the good work that we have done in terms of teaching, in terms of research, innovation, startup initiatives, and our efforts at skilling students so that they do well once they graduate has paid fruit. So it is actually apt that we start the events with an academic event, and that's where Department of Physics came to our rescue. They invited none other than Professor Jayant Murthy to be with us. Professor Arunav Kundu will introduce him, but I feel he needs no introduction. He's quite a household name, you know, as an astrophysicist. He's known world across, and we are really, really honored to have him here. And, you know, astronomy, astrophysics, space research being the current flavor of the time, I think it was very apt that he accepted our invitation and has traveled here. And he has a very exciting topic, and I think we are going to hear a very exciting story. I will request Professor Arunav to kind of introduce him, but I would also congratulate you again for your hard work, for all the efforts that you have put in for the last 20 years, 2 decades, to be here today in all its glory. We have really done well as a campus in its 20 years, and we look forward to many more decades of success and excellence as we move forward. Thank you very much for being here again, and Professor Kundu, you may introduce him.
So campus law dictates you have to go through all the Professor Kundus before you hear any astronomy talk. So it's my pleasure to introduce Jayant here. Jayant is an eminent astrophysicist, and his specialization is looking at the interstellar medium and studying the interstellar medium. And he's in particular a specialist in looking in the ultraviolet. And not only does he study it in the ultraviolet with various space-based instruments, he also builds a fair number of them. And some of our students are going to go work with him sometime in the next year. And other than that, he's also an eminent public speaker, and he loves talking to the public and giving science popularization talks. And this is somewhere in there. This is part of his expertise. He got his PhD from Johns Hopkins University, and he stayed there for a fair few years and did research work there. That's where I met him many years ago. And we've been trying to get him for a while. I'm glad that Jayant came in there. And I'll add one last note in there. When I asked Jayant to actually send him a short bio that I could talk about, Jayant said, "This is what ChatGPT says about me." So remember, students, your profs also know how to use ChatGPT. So with that, I hand it over to Jayant.
So I should just say that ChatGPT got it almost right. It gets the flowery language, which I don't do well, but it also told me that I had a PhD from University of Maryland, which I don't. And it told me that I did my undergraduate at St. Joseph's, which I did not. So, and it told me that I worked in cosmology, which I don't. So once you make the corrections, it works quite well. It's just don't do like that lawyer and submit your legal case as a ChatGPT thing. So anyway, thank you for coming. This is, I realize this is an unusual topic. And so I'll explain how I got into it. It's some work that I and a student did over 3 months in the summer. It's not actually my regular work. So, but you know, I grew up in the golden age of science fiction, and so this is something that I've always wanted to do. And it's my privilege to be here on your opening day of this 20 years of BITS. So now the younger people may not recognize this gentleman here. My first experience with him was on Chandrayaan, the first one. And he called me to Bombay. They had first they called me to the studio in Bangalore, and I was mildly critical of Chandrayaan because what people said is that we'll go and mine helium-3 on the moon. And I think that's a lot of nonsense. We won't get any helium-3 from the moon. And even if you get helium-3, we don't even know how to fuse deuterium and tritium. How are we going to do helium-3 at 10 times the temperature? And I said that. And, you know, these guys always want controversy. So he invited me to Bombay the next day. And, I mean, these guys work differently from us. They called me at 4 o'clock and said, get on the 5 o'clock plane. So, okay, I did it. It was fun. I went to the studio. And unfortunately, when I went there, it was the day India won the World Cup. And, you know, for me, World Cup means messy. But apparently this is a big thing. And so we got completely sidelined. And instead of half an hour or 1 hour, we got 30 seconds in between World Cup coverage. So that's my experience with Arnav. Now, so this is actually a valid complaint. If you talk to my director, they might agree with this. Why are you doing things that you're not paid to do? You're paid to work on the interstellar medium. Why are you doing this nonsense? And so I've always been fortunate that one, I've had pretty good directors, and B, I'm annoying enough that no one really wants to tell me not to do anything. So, you know, I just go ahead and do it. So one summer, the student came to me from Xavier's in Bombay, and he said, I want to do a project. So this was pre-COVID, but still, we did it all remotely. And I said, this is something that I've always been fascinated by. Just the whole Nightfall, which I'll get into later, could it have happened? Could you have a system that really looks like that? And the physics is pretty simple. So we thought, okay, let's just try it out and see what we do. So that's the reason we did this. And as a sidelight, I just want to say that I do think it is important that we maintain academics per se. And to me, academics means that you have the freedom to do what you're interested in, not simply what you're told to do. And you know, this is what we do as teachers. We teach people how to think. That's our primary purpose. It's not we're not responsible for the great advances of technology, but we set up an environment where people are not afraid to think of new things, not afraid to do new things. And so that was in that spirit we did this. So let me start by telling you about the story. The story was written in 1941 and by Isaac Asimov, and it was expanded into a full-length novel in 1990, Asimov and Silverberg. And you know, of course, this is always arguable, but it's generally considered to be the greatest short story in science fiction. It's been voted as that by various polls of writers and so on. So before getting into the story, we should first define what we're talking about. And so, as I said, I really grew up in the golden age of science fiction, maybe just a little bit after, in the 60s and 70s. And so then science fiction was pretty simple. Science fiction was just stories of the future. So if you go to Asimov, Clarke, Heinlein, these people, what were they talking about? They were talking about setting up bases on the moon, on Ganymede, on Pluto. And certainly you ask anyone from that era, and we were all so confident that humanity would have spread throughout the solar system. I mean, we're not crazy like Elon Musk, but this is just part of our part of our worldview. Now, of course, we know that it's a lot harder. Even to go to Mars, you're going to be hit by galactic radiation, and so it's incredibly hard to keep people alive. The Apollo astronauts, it was lucky that there were no really major storms at the time. So this is the Wikipedia, the source of all knowledge. This is the, now I guess ChatGPT may be replacing it. But anyway, this is the Wikipedia definition of science fiction. A genre of fiction dealing with imaginative content such as futuristic settings, futuristic science and technology, space travel, and so on, parallel universes, extraterrestrial life. And what has changed in science fiction from the time that I was reading it as a child is that science fiction is now not just exploring new technical ideas, just it's ideas of space. It's starting to go a lot more into the psychological stuff. You have things like Neuromancer, Robert Gibson, that really I find difficult to read. But now, in many ways, science fiction is a way to explore alternative literary themes. So you can argue when science fiction started. Maybe it started with Mary Shelley writing Frankenstein, or Frankenstein's Monster, 1818. I put this up and someone corrected me and said it was actually Kepler's Somnium in 1634, where he writes about people on the moon. But anyway, whatever you want to do it. But really, if you want to talk about the science fiction that I'm most familiar with, the hard science fiction, that really started in the late 19th century with the growth of science. So this was H.G. Wells, Jules Verne, from the Earth to the Moon. You have a huge cannon in Florida, which shoots people to the moon. I've forgotten how they got back, but they got to the moon in the cannon. And then you had space opera. So I'll just let this play. You might recognize the people and the music. So that, of course, is Queen, Freddie Mercury and Queen. So if you haven't seen the movie, I do recommend it. The whole movie is just like the trailer. It's a 1.5-hour version of what you just saw. And of course, the music by Queen is as Queen always is, superb. But this is the era of space opera. And so this was in the 30s and 40s. And the first of them was E.E. Smith, Doc Smith. And when you read him now, it really seems as though everything he says is dated, it's old. But really, he was the one who originated it. And so just because it seems old to us now, well, he was the one who made it, made the language like that. And then Edgar Rice Burroughs with John Carter of Mars. I actually liked the movie. Most people seem not to have. And then this was Flash Gordon, which came out in the 80s. This was all part of the genre called pulp science fiction. And the reason it was called pulp science fiction is that it really gained prominence in World War II. And because of paper shortages, they took the paper and they pulped it. And then they made magazines out of it. So that's why it's called pulp SF. And it's a pretty standard picture. You have a handsome, brawny man carrying a beautiful blonde woman. In this one, she seems to have fainted. And I guess that's also pretty standard. Oh, this was the 40s. What do you expect? And so this was space opera. And a lot of so this was when a lot of the magazines came out then. This was Amazing Stories. Hugo Gernsback, after whom the Hugo Award in science fiction is named. So a lot of this stuff came out then. Just after this, and maybe the pulp science fiction era led into this, into the John Campbell era. And he was another of these legendary editors. And so he wrote a few science fiction stories, but he was best known for the editing. And so he was editor of Astounding Science Fiction. And he really did identify and perhaps was responsible for this golden age of science fiction. So there are three authors who are primarily associated with this: Arthur Clarke, Robert Heinlein, and Asimov. Clarke was he was British, and he was gay, and of course in those times it was you may have seen remember Alan Turing. It was not a good time to be gay in England, so he lived in Sri Lanka for his entire life. And Arthur Clarke is responsible for many of the science tropes that we have, things like the geostationary satellites. He came up with that idea. The elevator from the Earth to space, that again is his idea. Heinlein was a strange man. Many people say that his ideas depended on who his wife was. His first wife was very liberal, and so in the first part of his life, he was also a leftist. He wrote probably the most famous books from that era are things like The Moon is a Harsh Mistress, where just teenage adventure stories. And then he divorced that wife, and then his second wife was very conservative. And that's when he came out with all these really strange books like Stranger in a Strange Land, which is absolutely unreadable. My son likes it, but I couldn't read it. It's terrible. And he has all sorts of, he becomes a libertarian. Many of you may know him from Starship Troopers, where the movie is actually much better than the book. And what many people don't realize about the movie is that it's actually anti-fascist. The book is a fascist trope. You can't vote unless you serve in the army. You have to serve in the military, otherwise you have to earn your citizenship by serving in the military. And so when this guy, Dutch guy, what's his name, Rupert Van Ziel or whatever his name is, when he made the movie, even the people who acted in the movie didn't realize that he actually made it as a parody of the book. But I liked it. And then Asimov, who will be the main focus of this. So Asimov was born in Russia in January 2nd, 1920. And there's actually a little bit of doubt about this, because this is when the Russian calendar was changing after the revolution. And so if you go back to the whatever it is, the Gregorian the Julian calendar, he might have been born in October. But he himself always said he was born on January 2nd. So we'll go by what he says. And he grew up in Brooklyn. He was one of these Russian Jews who fled Russia. His parents fled Russia for the U.S. And his excuse me, his family owned a series of candy stores. He himself spoke fluent Yiddish and English, and he read everything. And he read a lot of the science fiction of the time. Now, Jewish fathers, I guess, are a lot like Indian fathers, and they didn't want him to read fiction. They wanted him to read science. So why are you wasting your time reading science fiction? He said, no, look, it's science. It's science fiction. That means it's science. So his father bought it, and they allowed him to read science fiction. And he grew up in the New York public school system. He went to college at Seth Low Junior College, which is now an offshoot of Columbia University. At the time, this was the early 40s, late 30s, early 40s. At the time, there was still a Jewish quota. So no more than so many Jews could go into any particular department. And Columbia, I think, did not allow any Jews into their undergraduate curriculum. So Seth Low was one of their offshoot colleges. And then he got an MA in chemistry, and then finally he did a PhD in biochemistry in 1948. He did work on the war effort. This is him in the Navy yards. This is this is Asimov, this is Heinlein, and this is L. Sprague de Camp. So I haven't told you yet about L. Sprague de Camp, but the three of them here, they all went to the Philadelphia Navy Yards, and they all came out with completely different opinions of the military. Heinlein, as I told you, he said that you couldn't vote unless you served in the military. Citizenship is earned by serving your country. L. Sprague de Camp, he came out with a profound disrespect for the bureaucracy of the army, and where you sign things in triplicate and then whatever. But so he came out with he wrote a lot of books where he ridiculed the bureaucracy. And Asimov was, for his whole life, he was he was an activist for peace. And in fact, when Israel was founded, he did not he was opposed to the foundation of Israel, because he said that now you're just forming another ghetto, in a large ghetto, but still a ghetto in an Arabic sea. Now, in his career, he wrote hundreds of books, and it's kind of hard to tell how many books he wrote, because, as always, they're published under different names and so on. But probably a few, but hundreds of books, so maybe about 400 books. He became a let me back up a little. I told you he got his PhD from Columbia in biochemistry. Now, by that time, he had already started writing stories. And when he got his PhD, he was pretty tense. The night before, one of his short stories had been published. And this was on thiomotilene, I think it was called. And this was an imaginary compound where, when you took it, basically you took it when you drank, and you would have the hangover the previous day, not after you drink. And it was done as a spoof, and he sent it to John Campbell, and he told John Campbell, don't publish it until after my thesis defense. But Campbell, for whatever reason, he published it. And Asimov went up, and apparently he was terrified at his defense. He was terrified that someone would ask him about this. And he went through the whole thing and no one asked him. And then finally at the end, they asked him, so Dr. Asimov, what about the properties of thiomotilene? And he was so relieved at the end that he apparently collapsed in hysterical laughter. So he was made a full professor at Boston University, but he wasn't teaching after 1958 because that's when he started earning more money from his books than from his teaching. And does anyone want to guess what his salary was in 1958? It was $5,000. So he made more per year, not per month. So he made, so that's when he started making more money from his teaching. Now, he was a very mercenary man. So he found after the 50s that he made more money from his nonfiction than his fiction. So he switched to largely writing nonfiction after the 1950s. And in fact, one of my go-to books when I was a teenager was Asimov's 3-volume history of science, which is still, you read it now, and it's still remarkably relevant. It's well written and a good introduction to science. He died in 1992, and he actually died of HIV/AIDS, which he got from a blood transfusion. And at the time he died, it was still considered, it was still considered, I guess, disgraceful to have HIV, and so they hid that for some time. But anyway, so what he said after he died is that he'll be remembered for the Foundation trilogy, and this they had that pretty awful Apple interpretation where they completely changed the story. And this I never understood. I never understood about Rings of Power either. Here you have the greatest writers in the English language, Tolkien, Asimov. Why are you changing the story? You can't write as well as he does. Just keep the story. The story is good. Just keep it. And this was the problem with Foundation. They just changed the story. And the 3 laws of robotics, and you may remember the movie I, Robot with Will Smith, which also was not very good. So what he said is that he doesn't want to be remembered for any one book or even any sequence of books, but rather his total output. And this was something where he said that the total amount of quantity, total number of books, the quality of his books, and the range of subjects he chose, that was duplicated by no one else. And you can search for Asimov on Amazon, and you see a range of his books, many of which may not survive today. Now, his only rival in this was Arthur Clarke. And so apparently he and Arthur Clarke were riding together in a cab in Brooklyn one day. And they were arguing about who the greatest writer was. And he said this. He said, when I talk to anyone else, if I find that they have a body of science fiction, then I just tell them, no, forget the science fiction. Here, look at all these science books that I've written. And if they had a body of work in science, he would say, yeah, but forget about the science. Look at the science fiction stuff that I have. And Arthur Clarke was the only one who had a comparable amount of work in both. And again, I would, if you haven't read any of Arthur Clarke's books, there are some that are truly excellent. The 9 Billion Names of God, for instance, or Rendezvous with Rama. So these are excellent books and certainly well worth reading. And he's also written a lot of nonfiction. So the two of them apparently sat together in the taxi, and they came up with an agreement that, let's see, which way was it? As Arthur Clarke was required to insist to anyone else that Asimov was the best science writer in the world, and Arthur Clarke would be the second best. And in return, Asimov would tell everyone that that Clarke was the best science fiction writer in the world, and Asimov would be second best. And apparently they kept to this treaty till the end. Now, the story itself was inspired by a quotation from Emerson, and this is Emerson here. If the stars should appear one night in 1,000 years, how would men believe and adore and preserve for many generations the remembrance of the city of God? So what Emerson said is that if you didn't have stars at all, if you were in a dark world and suddenly you saw the stars, then that would show you the glory of God. But Campbell, he said that that if you had a dark sky and then the next minute you had stars everywhere, he thought everyone would go mad. And this was when Asimov was what, 20 years old. And so Asimov went off and he wrote the story, Nightfall. And this first appeared in Astounding Science Fiction in 1941. In 1991, he and Robert Silverberg converted it into a book. And by the way, if you asked Silverberg about the golden age of science fiction, he would say it started or ended a little later, because he would say that he was also a member of that. So in the story itself, what happens is that it's set on this planet, and the names of all the names change between the short story and the book. So I think I've used the ones in the book, and it's set on this planet, Kalgash, and it orbits its star, which is a sun-like star, at a distance of 1.2 AU. The sun goes around the Earth goes around the sun at a distance of 1 AU, and in this system, there's 5 other stars. Dovum, Tano, Sitha, Trey, and Patru. And no other stars are seen because it's always daylight. One of these stars is always in the sky. And because the system is so complicated, the law of gravitation was only discovered a few years before the story was set. So the guy who discovered the laws of gravitation, he was still alive. And because of the motion of these different planets, what they found is that there were cycles of destruction every 2,049 years, and this is how the book starts. The book starts with some archaeological diggings, and in those diggings they find layers of 2,049 years apart, and in each time the world ends in fire. I mean, not the world, not the world, but the civilization ends in fire. And there was a prophetic sect that actually had records of this. And so they said that in a few years, 2049 years was going to happen in a year or two. They said that again we would have this cycle of destruction. Now, Asimov himself did this purely from a sociological point of view. He wrote it from the context of Emerson's quote. Emerson's quote was if the stars should appear, then excuse me, if the stars should appear, then people will worship God. And what Campbell said is that if the stars appear, then people will go mad. So he was more concerned from the sociological point of view. He wrote a story not about the science, but about what the effect on the people would be. So he didn't really worry about the science. And this is actually typical of a lot of Asimov's science fiction. He wrote exploring concepts. He wasn't so concerned about whether it's possible or not, or the details, but he wrote exploring the concepts. And so what I thought for many years is, it's one of these things. It's buzzing around in the back of your head. You never quite get around to doing it, but it's still there. And so what I thought is that let's see if you can actually have this sort of complicated system, 5 suns and a planet going around. Can you really have it? And so I even tried some things, like I tried my own gravity simulator. And you would think it's easy, right? Because it's just Newton's laws. You have the sun at the center, you have the earth going around the sun. You would think that's an easy system to put on your computer. And so the way that you put it on the computer, I mean, the way we would do it on paper is that you would solve the problem. It's an analytical problem. But you can't do that when you have more than two bodies. Yeah, the three-body problem. I don't know. People always recommend the book to me, but I haven't read it yet. But the three-body problem is basically that you can't solve it analytically. You have, because you have constantly changing gravitational forces. And so the way you do it is that you use this, I guess, Newton-Raphson method. You have the instantaneous acceleration of the Earth to the sun, and you step the Earth all along a little on the tangent to the circle, and then a second later you then redo your calculations. So you do it around. And what I found is that even for that simple two-body system, just the Earth going around the sun, you all know the equations for that. But on my computer, it rapidly went awry. I couldn't do it for more than 1 million years or so. And the reason is just precision. If you try to do it at too big a time step, then you don't match that circle well. And if you do it at too short a time step, you never get to a longer time before you start running out of precision. Even if you use double precision, 1 part in 2 to the 16 or whatever, you still run out of, your errors still start adding up after a few million years or so. Now, of course, there are really beautiful gravity simulators out there. There's things like Universe in a Sandbox, which you can try, and those do a good job. They cheat a little. They don't do this exact thing. They correct every so often, I guess. But they do million. You can put in 1 million bodies, and you get a pretty good gravitational simulation. So you can do it, but you can't do it in a simple manner like I tried. And so what I told the student Smaran, I said, why don't we try this out? Why don't we look at the book? We'll see what all the clues are, and then we'll try to see, is this system physically possible? Because remember, Asimov didn't care about physics. He didn't care whether it was physically possible. He was just interested in looking at the sociological aspects. So is it physically possible? And so we did it. And I'll tell you what we did. But we did it, and we wrote if you know about Archive, we put it on this popular science group. And we just posted it there. We didn't expect anything to come out of it. It was just something we did over the summer. And I wanted the student to go through the entire process from understanding the problem to writing it up as a paper. And so we did it, we put it up, and immediately it started getting picked up. And by the way, coincidentally, just a few months before we did this, a group of students, ironically from Hopkins, they had done a study of the worlds of Game of Thrones. Because I've never seen the show, but apparently there's all sorts of weather fluctuations and stuff. And so they did a study in which they tried to see if this could be physically modeled. And I think finally they decided it was all just due to dragons. But they put it up. They put a little note in the acknowledgement. Please don't tell our advisors. We don't want them to know we've been working on this stuff, or they'll ask us why have you wasted your time. But anyway, so that was a little before, and that also got a fair bit of attention. So we put it up, and it was there, and almost immediately, this is the ADS reference, astrophysics data reference, and almost immediately someone updated the Wikipedia page to reference our article. So where is it? Here it is, further reading. Oops, I shouldn't have touched it, but anyway. So further reading. And so there it was, and then it got picked up by a number of different people. By this is a Spanish one that I just happened to see. I don't even know what it says. But we got interviewed by NPR. This senator, state senator from, I think, Illinois. He was a physics teacher. So somewhat surprisingly, he was a Republican, which one may not have expected. But anyway, he wrote to me and said, I'm going to use this in my physics class. And I got an email from a doctor in Texas, and the guy said, I've never really thought about this, but this is fascinating. Why don't you do Larry Niven, A Mote in God's Eye, where they have a Dyson sphere around the sun, which is something that is on my list to do. But anyway, so it actually did get a lot of attention, and we had this Physics Today did a podcast on us. And at the same time, a lot of the Kepler worlds were being discovered. So this is Kepler 64. And Dirk Terrell is actually, he works on the Kepler data, but he is also astro painter, I guess it's called. And so this is his image of this system, Kepler 64, where there are 5 suns from the moon of one of the planets. And so they picked him up too, and they interviewed him, and on the same podcast, they had the 3 of us. They had me, Smaran, and they had this guy, Dirk Terrell. So clearly that sort of stuff does exist. And sorry about the sound. But this is the worlds that exist from Kepler. These are all the worlds that exist from Kepler. Here's our own solar system. And so what you can see is that, you see the whole variety of different systems. So they have this thing called Tatooine, where you have a world with 2 suns. You have other systems where, as I said, you have 5 stars, a planet going around one of 5 stars in the system. And you would never have believed, when I was a graduate student, there was only one solar system. And everyone thought we understood how planets were formed. You have the hot, rocky planets near the sun. You have the cold planets far away from the sun. And now if you look at the Kepler systems, you have a whole lot of Jupiters, hot Jupiters, Jupiter-sized and larger planets that are in orbits closer to their sun than Mercury is to ours. How does this ever form? So there is a wide variety out there. But we did this before Kepler. Not before Kepler, but while Kepler was still doing its work. And so what we did was we started by collecting our data. We approach this as you would any scientific work. So you start by collecting data. Of course, we can't go and ask Asimov what he was thinking, but I imagine he would have liked it. I imagine he would have liked what we did. But anyway, we went to the book because the book has a lot more details than the short story. And I've forgotten which edition this all starts out to. I made him buy a book. I made him buy a copy of the book. And we just got all of the hard details that he talks about. All of the systems that we could use, all of the variables we could use in modeling a physical system. So as I told you already, it orbits a yellow star at a distance of 1.82 AU. We assume that if it's a yellow star like the sun, we know all stars are main sequence stars. All yellow stars are more or less the same. So here we have, it's a sun-like star. And then he tells us that these 2 stars, Trey and Patru, are a binary pair. They're white in color. Now, this tells you that if they're a binary pair, if they're a white pair, binary pair, well, they almost have to be white dwarfs. Because if you have normal blue stars, main sequence blue stars are all hot and huge. So if those were in a system, you wouldn't have any life at all. So this had to be white dwarfs. And here's another pair of another binary pair. And then you have this red star. And that has to be an M dwarf. So he told us the scale. The furthest sun from Kalgash is 110 light minutes. And so we took that. This is just outside the orbit of Jupiter, of Saturn. And then no other stars are visible. So this is a crucial thing. No other stars are visible. So what happened every 2,049 years, and this is part of the suspense in the short story, is that they work out that every 2,049 years there's an eclipse of the red moon, of the red star Dovim, by another planet that plunges the whole world into darkness for 9 to 14 years, because it plunges the whole world, 9 to 14 hours, because it plunges the whole world into darkness. So, we have a lunar eclipse that lasts for 8 minutes or something. But here is something that lasts for maybe a dozen hours, because it's a whole world. The whole world rotates, and it's all in eclipse. This moon is normally invisible. They don't know about it. So that again, they have to deduce it from the laws of gravitation. And as a side note, they had these amusement parks, and a new attraction in that amusement park was a cave of darkness. And so people would go in, and the place would be completely dark, and one in 5 people, 20% of the people would come out completely mad. So they shut down that attraction. But they knew this. Incidentally, so the short story ends at the time of darkness. And so what happens at the end of the short story is that the eclipse starts, and people look up and they see all these, and they see darkness coming. And then once darkness comes, it turns out that this whole star system is at the edge of a galactic cluster. And a galactic cluster is a place where maybe there's 20,000 stars, 50,000 stars, whatever. And so the sky is filled with stars. And so that drives them mad. So that's where he goes back to Campbell. The people don't see the glory of God. They go mad. And so that's where the short story ends. The short story ends with everyone going mad. And what do people do when it goes dark? If they want light? Well, they set everything on fire. So that's why the whole world is set on fire every 2,049 years. Now, in the short story, what the astronomers have done is they've set up a little bunker, and they put their families in the bunker, closed it up with lights and all that. So hopefully they didn't go mad in the bunker. But that's where the story ends. The story ends with the mob coming to burn down the astronomers in their observatory, because they said, look, you guys are the ones who are trying to warn us. I mean, this is a lesson to us all. You guys are the ones who are trying to warn us against disaster. Because you guys are trying to warn us against disaster, you must be the ones who caused it. And so they blamed the astronomers, and they went and killed all the astronomers. So maybe something we should watch out for. And the book then expands after that. And I personally didn't like the book very much, but it expands after that, and it goes through the reconstruction of society. This prophetic sect, they set up a religious theocracy, and these astronomers, the ones who were left over in the bunker, they come out into this religious theocracy. I think gangs of religious theocracies, and I've forgotten what happens in the end. I think it all ends happily, but I don't remember.
It doesn't end.
It doesn't end happily. There you go.
Except that this is what is required for civilization.
Okay. So they accept that a theocratic order is what is required for society to function. And okay, there you go. All right. So this moon, this sun Dovim, there are times when there are 5 stars in the system other than, There are 5 stars in the system, and all the other stars are hidden behind the world. This is the only star in the sky. And yet it's still bright enough to blot out the nearby cluster. So what we did was we just went through some numbers, and I'm not going to go through this in detail. If you want, you read the paper. It was really just done for fun. So just to show things. But what we did was we said we looked at the magnitude of the star. It's an M dwarf. We know what the magnitude of the M dwarf in the sky is, more or less. We knew the distance of the star, and so we calculated the orbit. We looked and saw what the brightest object you can see in the daytime sky is. And so when the sun is up, you can see Venus. And so that's Venus goes to like -4th magnitude. The sun is at -26 or -27. So you can see a difference of like 23, 24 magnitudes. And so we just went through that, just did plausibility arguments and so on. Let me not spend too much time on that. And then we tried to see what this second moon would be like. Now, the important thing here is that these guys, by their gravitational theory, they had deduced that the mass of this this moon was almost the same as the mass of Kalgash. So it was really a binary planet. It was not a planet and a moon. It was really a binary planet. And so using Kepler's laws, you can calculate the orbit. Of course, they'll both orbit around their common center of mass. And so you can imagine now why it took them so long to derive the laws of gravity, just because the system gets so complicated that it's not easy. Our own solar system is pretty easy. Everything goes more or less in a circle around the sun. So not hard to deduce, regardless of whether Newton was hit on the head with an apple or not. So we can calculate the orbit. This we know. We know from the book that the mass is roughly the same as the planet. And we know that the angular diameter is 7 times that of the star. Again, that he gives in the book. So now we look and see if the density is close to that of our own moon, then that would make this moon small and fast moving. If the density is much less, again, I'm not going to focus too much on this. This is just plausibility arguments. If the density is small, then the moon will be large and it'll be moved much slower. So anyway, we went through all this, and finally we came up with something that we thought was reasonable. And I think that this is in Wikipedia. Now, it turns out this is where we were going to, this is where we were going to end. And we thought, okay, maybe we can try some more things. Maybe we can try putting it in universe in a sandbox or something, or whatever. But then a few years, not too long ago, maybe a couple of years ago, this guy has gone through and done an incredible work where he's put everything in a gravitational simulator. And he's done all sorts of weird things. How many planets can you have in one orbit? And it turns out that in our Earth-Sun system, you can put, I think it's 100 planets. That would be in a train, and you would have a stable system. You have 100 Earths all in the same orbit. And so he looked at our system, and he said, no, this is not possible. He was very kind to us. He said, this interesting work. But then he said, no, this is not possible. And then he came up with some simulation. So we can't beat that. So it was fun while we did it. But we're leaving it there. Smaran himself, he went to Leiden, and he must have finished his PhD by now. I don't know where he is. I'll have to track him down. And let me end with Asimov's quote, which is, so the universe is not exactly not quite as you thought it was. You'd better rearrange your beliefs then, because you certainly can't rearrange the universe. And this is something I always tell my students, because they don't believe me. They think that when the minute someone writes it down, it is perfect. and the universe well, what the universe is doesn't matter. And this is important in astronomy because astronomy, uniquely amongst the sciences, is very data oriented. Fortunately, perhaps, we can't go and change the temperature of the sun by a couple of degrees to see what it looks like. I mean, I guarantee you, if you could, someone would have tried it. After all, they were not quite sure whether they would ignite the Earth's atmosphere at the time of the hydrogen bomb. So, fortunately in astronomy, we can't do that. But what we depend on is data. And so we have to depend on the data we get. And if our ideas don't correspond with the data, then we do have to change. So let me end there. I'm happy to take questions.
If you have any questions, feel free to. Otherwise, I can ask a question. So an astronomy question. So these guys they had only optical astronomers. They could have seen the rest of the stars if they had tried it.
Yeah, sure.
Some of them. So they didn't have non-optical astronomers.
Right.
Okay. So about the simulations then. So you said this guy went in there and did these simulations, and you can always get a system that gets 2049 at least one time somehow. So how many times can you get? What's the most stable one that you can get if you run a simulation with all of these stars?
That's an interesting question, and I don't know the answer because I don't even know how long the solar system will be stable. You've seen that stuff that, that Jupiter tugs on all the other planets. And so there's some simulations that show that in 100 million years or so, you all thought we had 5 billion years to live until the sun got old. But it turns out that maybe in 100 million years, the Jupiter's effects will tug Mercury out of its orbit, and it'll go careening through the solar system. So, you may only have 100 million years or so.
Other questions back there? Go ahead. You can use the mic. You can use the mic in front.
It may be very naive question because I'm not from physics background, but you said something 100 Earth. 100 Earth can be in that orbit, accommodated in the orbit.
Yeah, again, this is not my work. This is the work that this guy did. And yes, that's what he said.
But why that magic figure 100? Why not less than 100 or why not more than 100?
It could be. The exact number is probably 121. But I only remember round numbers. There's a story about Sherlock Holmes. Watson told him once that the Earth goes around the sun. And Sherlock Holmes said, "Oh, is that true? Now that you told me, I'll do my best to forget it, because my mind can only hold so many things." And so that's my philosophy.
There's a question from Hyderabad.
Yeah, Jayant, this is Shauri here. How are you doing?
Shauri.
Thank you.
Yeah,
you.
good.
Good. Thank you. And you have brought me back to my childhood days. This talk has been really fascinating. And, Jayant, I have a sort of a philosophical question. That when we were school kids, we were, brought up with books of Asimov and George Gamow. But it appears that things have declined. The science fiction from the Russian people have declined. So what's your view and comment on this? And this is for my own kids, because I don't see reading these books used to read. So what's your view and comment on this?
No, you're right, Shauri. I think certainly when I was young, it was all science fiction. Now it's become a lot more young fantasy. Things like J.K. Rowling, who doesn't know a plot if it hit her in the face. And I like the books, but there's no plot. So I don't know when it changed. You don't find a lot of the those books were really fascinating because brought us, a lot of us, into science. We came into science through two things. And you're the same age as me, so you know, the lunar landings, Neil Armstrong, I think must have been just the times. It was exciting times. It was when we really thought that we would go out and explore the solar system, and somehow that just foundered in the Cold War or something. Now I find that a lot of the science fiction is a lot more introspective, a lot more not so much science oriented as more of it's dystopian in many ways, and in many ways it's more psychological.
So does it depend on the sort of an audience? You mean that audience have changed over the period of time, and therefore those books have sort of become redundant?
I think the audience has changed, and I also think the writers have changed. I think people like Asimov and Clarke, they were happy to do what they were doing. They didn't have any pretensions of being great literary figures. And now I think many authors, they want to consider themselves the next Shakespeare. And perhaps, or they write fan fiction, which is of course much worse. So.
Use the microphone so that the others can hear you.
Thank you.
It's a little unfair. It's a little unfair calling the new authors, trying to be Shakespeare. No, there are some very good authors who are writing. They have gone back to space opera and they have made it as interesting with hard science in it. There are Stephen Baxter and Stephenson, people like this. They are doing wonderful work. So I think you would actually enjoy reading these authors if you loved Asimov and Clarke. You should try out some of these new authors, and then
yes,
I
that
think you will
Honor,
be less.
whatever her name is, those books. Yes,
Yes.
there are indeed some good ones. You know, I'm a little spoiled because just because I come from that time. You know, Asimov, Clarke, and to read anyone else, it's like reading Rowling after reading Tolkien. It's not the same.
No, I could recommend some really good books to you.
No,
Good authors.
I agree, and I'd be grateful for the recommendations.
Professor Kulkarni,
I have a question. It seems that, my exposure to so-called modern science fiction is primarily through movies. And what I see most in them is violence, extreme violence. And if I may be somewhat irreverent, also perhaps sex, I think. People having sex with machines, machines having sex with this, alien sex, this. Oh, God. The permutations and combinations are endless. So any comment on what this genre actually represents and why it is so?
Well, there have been some movies that have been quite faithful to the authors. And John Carter of Mars, for instance, I think that was one of the reasons people didn't like it, because it was faithful to the original. Dune, I don't know. I didn't like the book, so I never bothered to see the movies. But a lot of it, as I said, I think they've lost the spirit of the originals in a lot of the movies.
What is your opinion on this Star Trek series?
Star Trek. So Star Trek, I've never read the books. The same thing with Star Wars. I never read that extended Star Wars universe. So I guess I started with Star Trek first, the original Captain Kirk, and they were good. I preferred the Next Generation because the characters were a little more fleshed out. Especially, I'm not 10 years old anymore, and I can appreciate better women characters. Although Michelle Nichols, she apparently did have it's a very important. She had a very important role in bringing women and people of color into science. Apparently she was ready to quit the show, and MLK told her, "No, you're an inspiring figure, and so you please stay." And I haven't really done much of the Star Trek after that. I whatever reason. The best movie I thought was Wrath of Khan, where Ricardo Montalban plays Khan. Star Wars, I grew up with the first three, 1977 was when I finished high school, just before I joined college. And I remember it. It's, the three movies of that time were Star Wars, Exorcist, and Jaws, all three of which have really changed the genre. And I never watched The Exorcist because I'm not a horror person. Jaws I did see. But Star Wars was the one that's come. And if you ask me about the Star Wars, then only the first three are worth watching, and Rogue One, not the Abominations.
Mr. Barai, do you have a question?
There's a question in the back.
Thank you so much. It was wonderful hearing Professor Jayant here. I think you have taken us to the where I think totally a different out of space, you can say. Literally, you have taken us out. I was just kind of little curious that the kind of a changing landscape of kind of the fictional books are coming now. How do we really bring it to the classroom? Because I'm looking after now this curriculum review, where we can create an exercise of the student, because it has a lot of implications.
Yeah, no, so I use this for, as I said, I use this just as an example of a scientific study. It was a fun thing to do. And I thought rather than go through and use data from Galax or wherever, IUE or whatever, let's go through this book and just see what came. And I think that the physics is pretty simple. It's easy to understand. I didn't go into much of it, but it is pretty easy. So I thought it was something good to bring into the classroom.
We can discuss this after the talk. So
there's a question
at
at the
5
back.
o'clock, we have a photo session. So I will just end with the last two questions. And you have a question here. You've been waiting for.
So you mentioned that science fiction needs science, of course.
Yeah.
But what about the other way? Do they motivate the real scientists to to expand their scientific work or something?
I think it does. I think, again, I know that there was that generation, my generation, and we really did grow up with science fiction.
No.
And you talk to any scientist, I mean, maybe not any scientist, but you talk to a good fraction of scientists of my generation and earlier. And yes, it was reading. I think that reading is an important part of any scientist. And the stuff that we read, science fiction, I think what really got me into astronomy was perhaps the moon landing. I watched Neil Armstrong land on the moon, and I think that was what put me
Last
in.
question. Turn the mic on, please. Mike.
I had just two questions. Can you elaborate more on the sudden appearance of the clusters of stars and the time between two consecutive eclipses? Like it was 2049 years in the book, and how did it work around in your model? And also, what do you think of recent movies like Interstellar and like there was an adaptation of Asimov's movie, like it's a little old, the Bicentennial Man. So, what do you think of them?
Okay, so the first question was how did we work out the details in the model, right?
Yeah, for the sudden appearance of the stars.
So a lot of it we did not. We just, it was a 3-month project by an undergraduate student, and so we really didn't go into that much detail. It was mostly just plausibility arguments. And we just went through. I mean, you read the paper, but we didn't really go into that much detail. We just talked our way through things. Smaran was just starting to do some calculations, but then he had to go off to school. And the second question was, what do I think of Interstellar? And which other movie?
Bicentennial Man. It's based on Asimov's book about the same name.
Which one?
The Bicentennial Man.
Oh, Bicentennial Man.
Yeah.
Yeah. Interstellar I did not like because I thought it got too philosophical. All that stuff in the wormhole was too weird for me. I know that Kip Thorne worked on it and all, but it was too weird. Bicentennial Man, I liked I don't remember if it was a short story or a book, but it was a short story. And I thought Robin Williams did a good job in the movie. I did like the movie. I liked The Martian, although I haven't read the book, but I did like the movie. The story is that they've spent, someone calculated how much money it cost to save Matt Damon. Because they saved him in The Martian and then they saved him in Interstellar. And I think, was Ad Astra also Matt Damon? Or was that Brad Pitt? Anyway, Brad Pitt. But So it came out to some $1 trillion or something to save Matt Damon.
Okay.
And Sandra Bullock did not have to let go of George Clooney.
So it's 56 minutes past 4. We have another event. As I said, it's a very important day, so we have to close by now. But let me thank Professor Barai, Professor Sauri Banerjee, all my colleagues across campuses and students who are present here and made this beginning very special for us. And all of you for being here. And I think this discussion will go on forever. Kind of talks too. I think we'll all agree what a fantastic orator and storyteller Jayant Murthy is. And he transported us into various different worlds. I was sitting there and thinking what happens if the BITS Pilani campus is the center and Dubai, Hyderabad, and Goa are all moving along and all stations doing their own things. And what if BITS Goa was actually discovered 20 years before BITS Pilani was there, but it vanished and then came back, and now we are kind of celebrating 20 years. There's endless thoughts that comes to mind. But I think we had a fantastic beginning to this year celebration. Enough, a small token from us. I think if you consider, Jayant also means star, I think.
It's the name of Krishna.
Yeah, and you can have Kundu, you can come. You can at least have 2 Kundus at 2 months.
Jayant, please do visit Hyderabad campus. Jayant, we look forward to see you again in Hyderabad.
Yeah, if we allow, we'll see. Okay, let's disperse and then run. Thank you.